Okay, the mean value theorem is a little bit different than Rolle's. Rolle's is a special type of the mean value theorem. Okay, so for the mean value theorem, we still have the first two conditions similar. If f of x is continuous on the closed interval, and if f of x is differentiable on the open interval, this time, then the derivative is equal to the slope of the secant line. So essentially, the slope of the tangent line, there will be a point C, there will be a C value, where M tangent and M secant are parallel. So that's another way to do it, is that these two, at a given C value, the slope of the tangent line, the slope of the secant line, they'll be the same. They'll be parallel. All right. First thing that you have to do is you have to find, we have our 2x values. So you plug the 2x's into, okay, so when we plug both of these x values, or a and b, -3 into the function and 3 in the function, we get a height of 9/2, and 9/2 is 4.5. Most of the time I have students leave it as 9/2, but 4.5. All right. And now what we're going to do, we're going to find the slope of the secant line. So we plug it into the slope formula, y2 minus y1 over x2 minus x1. We see that the slope of the secant line is 0, which is good because now this says that when we find the derivative, we know that m secant is going to equal m tangent. So let's find the derivative of this function. So the derivative of this function, the 2x comes down in front, and that's over 2. So the derivative is x. So we're going to set 0. So this is m secant, and we're going to set it equal to m tangent. Well, this is what that means. So let me go ahead and, okay, so I drew the diagram. So we've got a parabola, and notice the slope of the secant line right there is 0. It's a horizontal line at 0. And then where x is equal to 0, there's a tangent line, and that slope is also equal to 0. So those two lines are parallel. So on any given, so let's say you have a graph that looks like this. And we say that this is going to be the interval from this point. Well, look at that. Well, that's not necessarily what I wanted to show you, but we'll do another one. Okay, so this is a polynomial, so we know the function is continuous, which means it's differentiable on any of the intervals on a polynomial. Then there will be a point where m secant, the slope of the secant line, will equal the slope of the tangent line. So let's find m secant first. So when we plug -1, we're going to get a value, and we plug 1 in, we're going to get a value. So -1 cubed is -1. Subtract. -1 squared is 1. Add those together and you get 0. And then when we plug 1 in there, we have 1, subtract 1, plus 2. So that looks like that's a height of 3, or I'm sorry, a height of 2. Okay, so those are our two y values and x values. So m secant will be 2 subtract 0 over 1 subtract -1. So that's 1 plus 1. So this is 2 over 2. So m secant is 1. Well, down here, we're going to set m secant equal. Remember, the then is m secant will equal m tangent. So we find the derivative now. which is 3x squared minus 2x. We're going to set the derivative equal to the m secant. And now let's see, I can pull an x out of there. That leaves 3x minus 2. So we know one of the x's equals 0. And one of, oh, we're not done yet. Whoops, sorry. Well, we want this left side to equal 0, so we're going to subtract 1. And now let's see what we can factor this to. Let's see, that will be negative 3x. That will be positive x. Add them together, you get negative 2x. Good. So now we have our 3x plus 1, x minus 1. So this x, the opposite of 1, is negative 1. And divide 3, the opposite of multiplying 3 is dividing 3. And this x equals 1. So it looks like there could be two locations with our c value. So if we do the curve sketching, let's see. And we know this touches right there. I don't know, it could look something like that. And then the slope of the secant line between negative 1 and 1 well, looks like there's a point that's parallel, and there's a point. So these two points right there, negative 1/3, looks like about right, and at positive 1, these two tangent lines are parallel to the secant line. All right, let's see if they ask us if it is. So down here, determine if it exists between negative 4 and negative 1. Well, in this case, where x is equal to 0, so that means since the interval is over here, you will be able to apply. Rolle's theorem on the interval. All right, that's it for this one.